Hello everyone, this is Dr. Santosh. So today we will be talking about regulation of mitochondrial beta oxidation. So regulation of mitochondrial beta oxidation occurs at mainly at two steps. First step in adipocytes, adipocyte, and in adipocyte lipolysis occurs, lipolysis occurs. So this regulation occurs at lipolysis, and second step is at tissues where fatty acid oxidation happens, like tissues like liver and muscle. So here fatty acid oxidation happens. So regulation occurs at CPT1. CPT1 means carnitine palmitoid transferase 1. So this enzyme converts fatty acyl coenzyme A into acyl carnitine and facilitates transport of fatty acids. Now this is so as I told you, in this is first step where this regulation of beta oxidation occurs is lipolysis at adipose tissue. So in during we were talking about beta oxidation. Beta oxidation occurs during fasting condition. In fasting condition, you all know fasting condition is defined by glucagon. So glucagon is very high during fasting condition, and glucagon means high CAMP inside the cell, and then high CAMP is equal to protein kinase A, and then protein kinase A means phosphorylation of protein, phosphorylation of proteins. And this protein, among this protein, hormone sensitive lipase is one of this protein. So this protein is phosphorylated during fasting condition, and this phosphorylated form is active form, and this phosphorylated hormone sensitive lipase will do lipolysis. What does it do? It converts triglyceride to fatty acid plus long chain fatty acid, long chain palmitic acid. So because palmitic acid is the predominant fatty acid, palmitic and stearic acids are predominant fatty acids in adipose tissue, and glycerol. And they now this is lipolysis. Now this travel through blood, and through blood it will reach tissues like liver and muscle. In liver and muscle, so this fatty acid will be activated into acyl coenzyme A, and this acyl coenzyme A will be converted into acyl carnitine by this CPT1. And this is how, if acyl carnitine is formed, so acyl carnitine can easily pass through inner mitochondrial membrane, and this, CPT is present in outer mitochondrial membrane. This reaction happens in intermembranous space of mitochondria, intermembranous space of mitochondria. Now what will happen then after crossing of acyl carnitine? So acyl carnitine will again convert into acyl coenzyme A through CPT2, which is present in mitochondria. Beta oxidation will happen. Now because of beta oxidation, there will be production of what? NADH plus FADH2. So this is the product, one of the product of beta oxidation plus acetyl coenzyme A. Now what will happen? So This is first regulatory step that happens inside adipocytes, and this second regulatory step occurs. Second regulatory step occurs in um, muscles and liver mitochondria. So what happens during fasting condition? It is uninhibited, so it is activated, because during fasting condition there is no malonyl coenzyme. Where does this malonyl coenzyme comes? This malonyl coenzyme is produced during fed condition, not during fasting condition. During fed condition from acetyl coenzyme A by enzyme called acetyl coenzyme A carboxylase, which is rate limiting step of, this is the rate limiting step of fatty acid synthesis. Fatty acid synthesis. And therefore, during fat, and this is the molecule when it inhibits during, this inhibits the CPT during fatty acid synthesis, so that fatty acid synthesis and beta oxidation will not happen together. But during fasting condition, this molecule is not there. If it is not there, this molecule is free to perform its reaction. Therefore, during fasting condition, this molecule, this CPT, will convert acyl coenzyme A into acyl carnitine, and thereby facilitating the movement of acyl carnitine into mitochondrial matrix and then beta oxidation. So now beta oxidation, this is second step. This is how just remember very important point. Malonyl coenzyme during fed condition inhibits, and during fasting condition it is uninhibited. But here during fasting condition it is phosphorylated, and in fed condition it is dephosphorylated by insulin. So this enzyme in adipose tissue will undergo phosphorylation as well as dephosphorylation. Now, so this is the main two important steps. So what will happen? One step always happens in during in metabolism. When there is high product, it will inhibit beta oxidation. This NADPS and FADH, if it becomes high, they will also inhibit. This is called feedback inhibition. Product will inhibit its own reaction. This is called feedback inhibition, FBI, feedback inhibition. So this is a feedback inhibition that happens through NADH and FADH2. So you can see here, so fatty acid synthesis, fatty acid after being synthesized, so it will undergo beta oxidation. Malonyl coenzyme will inhibit this here, malonyl coenzyme during fed condition, and then third third regulation is through NFADH2 and NADH2. Among this, just remember, don't forget this important two step, 1 and 2. Don't forget this. So it is not that difficult to remember. All this is feedback inhibition. Feedback inhibition is happens in almost all pathways, and this reaction we will talk a bit later. So this reaction, synthesis of this malonyl coenzyme A from acetyl coenzyme A is facilitated by insulin, because it happens during fed condition. So this is formed. I have already discussed this malonyl coenzyme A. This malonyl coenzyme A synthesis occurs during fed condition, and then fed condition acetyl coenzyme A carboxylase synthesize this. Now this is inhibited by one enzyme. Means this enzyme facilitates beta oxidation. Let's talk about this enzyme. This enzyme is very important, and that is especially during exercise. So exercise, how exercise? So answer to the question, how exercise induces fat oxidation. So answer lies in the fact that exercise will increase AMP, and this AMP will activate AMP kinase, and this AMP kinase is such enzyme that it will activate activate beta oxidation oxidation and and inhibit inhibit fatty acid synthesis. Actually, this is such an enzyme that it will activate all type of catabolism. It will activate catabolism. Catabolism, especially catabolism, is responsible for production of energy. So energy, it will activate energy producing reaction, this AMP kinase, and inhibit energy requiring reactions, inhibit anabolism or energy requiring reaction. This is very important enzyme. Just remember for the time being, energy requiring reaction. If you want to know about this AMP kinase in more detail, how this AMP kinase is beneficial for health, how increase in AMP kinase activity in muscle, in liver increases, ensure our good health. If you want to know, let me know in the comment box. I'll make video on this. Thank you for watching, and I'll tell you to subscribe this channel. Thank you.